Today, we're going to be cosmic detectives. We're opening up a case file on a brilliant swarm of stars, a place where you can see creation and evolution happening right before your eyes. And our subject? It's the open star cluster, Messier 36. So our investigation starts a long, long way from home. Messier 36 is located a mind-boggling 4,340 light-years away in the constellation Auriga. To put that into perspective, the light that we're seeing from it tonight actually started its journey to Earth right around the time the Great Pyramid of Giza was being finished. Just think about that. And you know, that immense distance is hiding a mystery. This isn't just some pretty picture in the sky. Nope, it's a dynamic, living community of stars. And just like any community, it's got a past, a present, and a future. So the big question for our investigation is this: what secrets are really hidden inside this incredible swarm of stars? Okay, let's crack open this case file. First, we'll get to know our subject a little better. Then, we're going to follow 3 key lines of inquiry. We'll count the cluster's pairs, we'll hunt for planetary nurseries, and we'll take the cluster's pulse. And then, at the end, we'll put all the clues together to solve the case of M36. First up, let's get a proper introduction to our main subject of interest. It's the star cluster officially known as Messier 36, or NGC 1960 if you're an astronomer. Now, what exactly is an open star cluster? Well, you can think of it like a stellar nursery's graduating class. These are all young stars born from the exact same massive cloud of gas and dust. They're basically siblings, still kind of hanging out together before they eventually drift apart and go their own separate ways across the galaxy. And this is where our subject gets really interesting. M36 is young, like very young. At only about 25 million years old, it's basically a cosmic teenager. I mean, for comparison, our own sun is a middle-aged 4.6 billion years old. And this youth, that's a critical clue. It makes M36 the perfect laboratory for studying how stars evolve in their early, really dramatic stages. Okay, let's move to our first line of investigation. And this one focuses on a really fundamental question. How many of these stars are flying solo? And how many are, in a relationship? This first clue is all about the company that stars keep. The key piece of evidence here is something astronomers call the binary fraction. It's basically just the percentage of stars that are locked in a gravitational dance with a partner. Now, this isn't just a fun fact. It's a vital sign for the cluster. A high number suggests a pretty calm upbringing, but a low number, that hints at a chaotic past where gravity has just ripped stellar pairs apart. It tells us a story about how the cluster's been shaped since it was born. So how in the world did scientists count all these pairs? Well, they used this really clever 2-step process with data from the Gaia Space Observatory. First, they looked at what's called proper motion, which is basically checking which stars were all moving together in the same direction, kind of like a flock of birds. Then they used parallax, a technique that lets them calculate a star's distance to confirm which ones were truly part of the cluster and not just photobombing from the foreground or the background. And the results? They were fascinating. They found the binary fraction was between 30 and 50%. Now, that might sound pretty standard for a cluster of this age, but it's an absolutely crucial piece of the puzzle. It tells us that M36 has had a relatively stable childhood, without the kind of intense gravitational chaos that can break these pairs apart. But in the process, they stumbled onto something they weren't even looking for. Hiding in the background were 2 entirely new groups of stars also moving together. And this is just a perfect example of a core truth in science. Sometimes the coolest discoveries are the ones you make by accident. All right, let's move on to clue number 2. Knowing how old this cluster is, our investigation now shifts from the stars themselves to what might be forming around them. We're officially going hunting for the telltale signs of planetary nurseries. This timeline right here shows us something amazing about where M36 sits in the grand scheme of things. So, according to our best models, the first 10 million years or so are for building gas giants like Jupiter. But that window from 10 to 30 million years, right where M36 is, that's the sweet spot. That's for forming rocky terrestrial planets, like Earth. So, are there signs of this actually happening? You bet. Using the Spitzer Space Telescope, astronomers looked for excess infrared heat, which is a key sign of these dusty debris disks where planets get made. And they found them, a lot of them. More than 30% of the hotter, more massive stars and over 23% of the sun-like stars showed evidence of these planetary construction zones. And this brings us to a really crucial point, which is summed up perfectly by the researchers themselves. They said, and I'm quoting here, that because M36 is in that 10 to 30 million-year-old window, it's at an interesting epoch for planet formation. We could be looking at Earth-like worlds being born right at this very moment. Okay, for our third and final clue, we're going from the space around the stars to the stars themselves. We are literally going to take the cluster's pulse by looking at its vital signs, the rhythmic blinking, fading, and spinning of all its stellar residents. So, in the very first high-precision survey of this kind for this cluster, astronomers took observations for over 3 years. And boy, did they hit the jackpot. They discovered 72 times new periodic variable stars. These are stars whose brightness changes in a regular, predictable cycle. And this wasn't just one kind of variable star. No, they found a whole zoo of them. This table just shows you a few examples. You've got stars that pulsate because of heat trapped inside, you've got slowly pulsating stars, and you even have what are called rotational variables, which are like these cosmic lighthouses spinning around with massive star spots. So what's the big deal with all this? Well, the crucial point is that each of these different rhythms tells a story. Just like a doctor can learn about your health from your heartbeat, astronomers can use these stellar pulses to understand the inside of a star, its structure, its mass, and where it is in its life cycle. It's an unbelievably powerful tool that reveals the inner life of the whole cluster. All right, we've gathered all of our evidence. Let's head to our case summary and see what these clues, when you put them all together, really tell us about Messier 36. So, here's the story in a nutshell. Clue number 1. The binary fraction, that gives us a window into the cluster's past, showing us how it evolved. Clue number 2. Those debris disks, points to the future, the very real potential for entire solar systems to be forming as we speak. And clue number 3. All those variable stars, that shows us the present, a snapshot of the cluster's vibrant, pulsating, active life right now. So when you put it all together, the picture becomes crystal clear. M36 isn't just a static object or some random spray of stars across the sky. It's a living, breathing cosmic laboratory, a perfect self-contained environment where we can watch the fundamental processes of the universe just unfold. And that leaves us with one final, pretty tantalizing thought. By focusing on just this one teenage cluster, we've found hidden star groups, we've seen nurseries for new Earths, and we've taken the pulse of dozens of stars. It just makes you wonder, if this is what's hiding in one small patch of the sky, what else is out there just waiting for us to investigate?